issue.
Seems to be
Okay.
working.
All right. So I'm very pleased to have
Okay.
Todd Tietjen joining us today. Can everybody hear me now? Okay. So Todd graduated in 1990. He was one of the first students that I worked with when I was a very young assistant professor. I think actually he was the first student that worked with me on research. And anybody who's taken one of my classes, you've heard the story about the pig manure spill that was that one of my students picked up as a dissolved oxygen low in the Genesee River. That's the student, Todd. So if you've heard that story from me, that's where it came from. I don't know if you even remember that, Todd, do you? Okay.
I lost you for a second.
Okay. Anyway, Todd went on to get a master's degree from Southwest Texas State University and a PhD from the University of Alabama. And now is works as a regional water quality manager for Southern Nevada Water Authority. And basically, I think he's in charge of Lake Mead, from what I understand. All right, so I'm going to turn it over to Todd at the end. If people have questions, just put in the chat that you have a question and I'll call on you. Okay. And so Todd, you can share your screen now and hopefully this will work.
So hopefully you can see that.
Yes. Yep.
Yes, maybe.
Yes. Yep. Yep.
Okay, good. All right. So okay. I talk about a variety of things, all tied to this sort of overarching topic of the past 20 years of drought that the Colorado Basin has been suffering through. I don't know if the basin itself cares a whole heck of a lot, but all the states do. Come on now. So I want to just when talking to groups like this, give this rundown of myself because I think there's some informative stuff, hopefully for students at least. So I was born in Queens, raised in Westchester, but my father's family was from Queens. My mother's family was from Lockport. So I spent the first 20 years of my life driving back and forth across the state for every holiday, which is how I wound up at Alfred. Graduated in 1990 with a major in environmental studies, minors in both biology and geology. Not chemistry for those of you that are at least take it easy on me. I throw in here that and I hope some students take solace in this. I was not a great student. I became a better student, but I was not great. As Michelle said, I got a master's degree at Southwest Texas, which is now renamed itself the much more prestigious Texas State University at San Marcos. My thesis there looked at dissolved oxygen in a reservoir, which is where I got into reservoir limnology, which is what I really do now and what I call myself. Moved on from there to the University of Alabama, where I got a PhD. Unmute. Sorry about that. I back?
I can hear you now. Yeah, but I'm not seeing your slides right now. All right, patience, folks. We'll get there.
I'm gonna try to change offices and see if I can get a better connection.
Okay.
I suspect it's my end that's dropping it. Of course. I should have a better connection here. So let me go back to this. Share. Okay, I'm not sure where I dropped out, but anyway, the PhD worked on a small reservoir in Alabama on bacteria for my interest. And my advisor's interest was the interactions between clay particles and dissolved organic carbon and dissolved enzymes. So I got to call back on some of the work I'd done at Alfred, looking at clays and trying to apply it or interact it with some biology. Moved on to a postdoc with the Grand Canyon Monitoring and Research Center, which is a branch of the U.S. Geological Survey. By far the most fun job I've ever had. Spent 2 years living in Flagstaff and working on Grand Canyon, or the Colorado River through Grand Canyon. Was hired to do nutrient and carbon dynamics in the river. Wound up working with non-native fish removal, trout, which have been introduced to the river to encourage the recovery of the humpback chub, which is a funny looking endangered fish that is only found in the Colorado River and is pretty threatened by the introduced fish, the introduced trout. Moved on from there to the Department of Wildlife Fisheries at Mississippi State. Taught limnology and wetland ecology there. That's about all I have to say about that. It was the best job I was offered. Turns out I'm not a Southerner and never will be. And for the past 12 and a half years, I've been with Southern Nevada Water Authority. The real interest in working here, I'm not a Las Vegan either, but it's the opportunity to work on Lake Mead and the Colorado River. And beginning in January, we'll actually be merging our regional water quality group with our research and development group. So I'll be overseeing not only the Lake Mead work, but the research and development in water reuse, water treatment technologies, and an emerging group that's just been formed in biological approaches in water treatment. So let's go next. So I also like to throw this slide up, though it sounds like your speakers have been further afield than even me. So Alfred there on the right, Lake Mead and Lake Powell on the left. We've got a continent dividing us. That divide is meaningful in a lot of ways that aren't just geographic. So if you look at the Google Earth image of Alfred from 350 miles up, you can see the Finger Lakes. You can see 3 of the Great Lakes. You see a lot of green. Compare that to what I see when I look at the Las Vegas area from 350 miles up. Well, we've got Lake Mead there, Lake Powell there. It's all Grand Canyon in between, the Colorado River through Grand Canyon in between. A little bit of green. I don't know how it comes across Zoom, but the north rim of the Grand Canyon is green. Some of the area around Flagstaff is green with forest, but a lot of desert landscape. And it's really a very arid environment. So as Michelle said, as I've said, so my work now is really focused on Lake Mead because this is the major water source for Las Vegas. It's also the major water source for a lot of Southern California. It is the largest reservoir in the country by volume when it's full. At the moment, it's about 47% full. That's about the fullest it's been this year. Lake Powell is actually a larger reservoir based on area, but not by volume. It's a little bit fuller. It's maybe in the 60% range of full right now. And that's at the other end of Grand Canyon. Lake Mead itself is entirely dependent, or almost entirely dependent, upon the Colorado River for its water. 97% of the water comes through the Colorado River. We benefit from having Grand Canyon and Lake Powell upstream, two more natural resource areas, natural parks. Lake Mead itself is a national, recreation area. So it's all a very protected watershed for about 400 miles upstream. There are a few other tributaries. They were on the last slide: the Muddy River, the Virgin River, and the Las Vegas Wash. They only provide about 1 to 3% of the total flow that comes into the river. It's managed by the Bureau of Reclamation for the water operations, so they control the dam, and the land and activities on the lake are controlled by the Park Service through the Lake Mead National Recreation Area. A lot of people don't know that the main reason that Hoover Dam and Lake Mead were originally built was for flood control. It was to control floods that ravaged far southeastern California in the very early 1900s. Today, its really most important role is providing water to about 25 million people. About 3 million, 2.5 million of those are in Las Vegas, but most of those are in California and Arizona. And then it irrigates over the water from it irrigates over 1 million acres of crops. Also, in the spirit of sort of setting up the background for all of this, we need to talk a little bit about the Colorado River Basin and the political boundaries that have been set up. So there are 7 states plus Mexico that are part of the Colorado River Basin. This black line through the middle, hopefully you can see the cursor, divides the basin between the upper and the lower basin. The upper basin generally does not use all of the water that it's allocated. The lower basin uses all of and more than the water that it is allocated. And then these hatched areas, Southern California, the Imperial Valley, parts of New Mexico, parts of the Front Range, they are parts of the United States that are outside of the drainage basin that then receive Colorado River water. So it is piped, tunneled, or canaled to these places outside of the basin itself. There are whole talks that could be given on the politics of this. I tell people that I'm glad to work in water quality, not in water quantity or water resources. The politics of this, they employ about a dozen people with us. Every Colorado River state has a Colorado River Commission of, insert the state name here. So there's a Nevada and Arizona, California. It's also important, and I take it as hopeful, that most of the disputes are settled by consensus, not by courts. That all the states work very hard to stay out of court in deciding these things, mostly because they're afraid of what the court might do, but because they've found over 100 years now that working together tends to work better. Okay, I think this is the last of the sort of primer stuff. Talking about water rights in the West is very different from talking about water rights in the East. In the eastern states, most of those east of Texas, except for Mississippi, because Mississippi has to be different, if you have access to the water body, you have rights to use the water. In the West, because they're drier and because of how they were settled, the right of prior appropriation is what dominates everything. That if you are first in time to use the water, you are first in line to get the water, no matter what the water year looks like. The example in that little image down there is that we have a downstream senior water rights user who started using the water in 1910. Even though they're far downstream of that junior water rights user, because they have a 60-year time advantage, they can use every drop of their water allocation before that 1970 user can use any. In wet years, that's not a problem. In dry years, in 20 years of drought, it makes the lawyers happy. And sorry, we have announcements for I work at a water treatment plant, and we have announcements that come over every once in a while. That junior user during wet year is fine, but in long periods of drought, they're at great risk. So Hoover Dam is the only reason that Lake Mead is here. Some of you have probably heard of Glen Canyon Dam and Lake Powell, the second largest reservoir in the country, the second largest reservoir on the Colorado River. Both of these were spectacular canyons, spectacular landscapes before they were impounded. I'm not a reservoir limnologist because I love reservoirs. I have some sympathy for the folks who'd like to take down Glen Canyon Dam. I don't think politically they'll pull it off, but I understand their desire to have that canyon back. I'm a reservoir limnologist because they're really interesting aquatic systems, to me, much more interesting than just regular normal lakes. So Hoover Dam, everybody probably knows that it's a Depression era project, constructed in 5 years between 1930 and 1935, had a lot of cheap labor available, so they got it up fast. Then between 1936 and 1961, they put power plants in. That took that long because they only added generating capacity as they needed the electricity. So it wasn't until 1961 about that they needed all of the water, all the electricity they could produce, and they put in the last of the turbines. It's a gravity arch construction, which means it's really just a big chunk of concrete held in place by gravity. It is not anchored into the walls. It is not held in place by the walls of the canyon. It's gravity that holds it there. About 1,200 feet wide at the top, 600 feet wide at the bottom. So half as wide as at the bottom as the top, as pictures show. Took a lot of concrete, has 17 generating units. There's 8 on the Nevada side, 8. 8 on the Arizona side, and 1 generator that just provides power to the dam itself. And in total, it provides, when the lake is full, about 2 gigawatts of power. They've spent a lot of money in the past decade or so retrofitting all of the turbines so they can produce more energy at lower flows because the lake has been down and they don't have the head that they would like to have. I'm just going to cycle through a couple of pictures. So this is one of the original planning meetings, bunch of men deciding where to put the dam. That background is exactly where the dam wound up. Some initial blasting to clear the canyon walls. At this point, they had built the coffer dam and built 2 tunnels. You can see the 2 tunnels coming out on either side. This is where they diverted the Colorado River through to build while they were building the dam. These are the high scalers. Their job was to go up and down the cliffs of the canyon and clear it of loose rock. It wasn't really to drill in so that they could anchor the canyon, to anchor the dam into the canyon. It was just to get rid of loose rock the concrete wouldn't stick to. There's quite the mystique around these guys in Boulder City where I live, because basically they are the reason we have a town. Again, high scalers at work. The dam under construction. One interesting fact of the dam, or at least to me, is those of you who've seen concrete laid before, you know that usually there's steel rebar put into the concrete to reinforce it. Hoover Dam has no rebar in it. Instead, what they did to speed up the overall curing of the concrete is they ran cooling pipes, ran cold Colorado River water through it to cool the concrete faster so it would set faster, and then just left those cooling pipes as the reinforcement. This is the intake towers on the Arizona side. I show this picture. There's never this many announcements during a regular workday. I like this picture because it shows that at the time of construction, they set the intake towers over 100 feet off of the bottom of the reservoir because of sedimentation. With the construction of Lake Powell upstream, sedimentation is now net zero. We get a little sediment, but the sediment that's already there compacts, so the sedimentation is no longer a problem. And then finally, Hoover Dam and Lake Mead during happy times. The lake was full, probably the 1950s. it filled relatively rapidly, and then we move into this story. So looking at how full the lake has been over time, so closed in about 1935, rapidly filled, had to have been a series of large storms plus no other major impoundments on the Colorado River upstream. Basically stayed full through the 1940s, 1950s. The drought of the 50s caused it to drop about 100 feet in surface elevation. That rapidly returned again, few dams upstream. The 1960s drop is when they closed Glen Canyon Dam. It took about 20 years to refill the lake after that. So the filling of Lake Powell and Lake Mead took about 20 years. Had about 10 years, 15 years of good, almost full, nearly full conditions, ending in the late 90s, just about 2000. And then except for these 2 years, 2 good years, we've been downhill or now stable for the past 20. This good year around 2011 is pure politics. This is when Harry Reid was the leader of the Senate. Lake Powell was very full. They had what we like to call excess water, what they like to call their reserve. And Harry Reid really twisted their arm and made them release excess water so that Lake Mead levels would go up. You see that lasts about a year, maybe 2 years, and then we're back down in the range where we had been. I show this picture because at the time it was taken, this was the fullest and the shallowest, the emptiest that Lake Mead had ever been. Those are those intake towers that I showed from below a minute ago. In 1983, the dam was literally overflowing. That's the overflow spillway on the Arizona side. There's the one on the Nevada side that was also overflowing. Combination of good snow years and high rainfall led the lake to be full. In 2016, we reached 1,076 feet elevation. That was a critical value because at 1,075 feet elevation, the basin states, the lower basin states start taking shortages. So this was 1 foot above that. We've dropped below it. I'll come back to some of the complexity of that later on. But this is about as full and as empty as the lake has ever been. At 1,076 feet, that water at the front end of the dam is still about 300 feet deep. This is a V-shaped reservoir, and if you think about your surface area, your volume relationships, there's a lot more water stored when the lake is that 100 feet higher than in that bottom 300 feet. So that bottom 300 feet is about half of the volume. The top 100 feet is about the other half. Looking at this more recently, just the drought period. So I've got that purple line at 1,075. You can see we've dipped below that a couple of times. That's when, in theory, the basin states, Arizona, California, Nevada, could start taking shortages. Arizona takes them first, Nevada takes them second, California takes them third in order of priority of their water rights. The tricky part of that, or the lawyerly part of that, is the only day of the year that matters is January 1st. As long as the water level is above 1,075 feet on January 1st, there's no shortage for the entire year. So they will work very hard to conserve water beginning in December to make sure, if it looks like they're going to be short, they'll conserve in December if possible to keep it up. The two red lines are the Hoover Dam intakes. That upper Hoover Dam intake is within about 50 feet of where the surface of the lake is. At that point, they would have to shut off that intake. They start sucking water through the intake, and they would have cavitation problems with the turbines, and electricity will be shut off. The lower intake, we've still got more than 150 feet of water over that, but that reduces their ability to produce electricity, which again matters immensely to California, immensely to Arizona, and to some extent to Nevada. And then that bottom blue line is our drinking water intake, which we've constructed since I got here. You'll see we can now withdraw water for Las Vegas after water can no longer be released downstream to California or Arizona. I laugh at the Californians for this, but if we get down to this 900-foot level, the everything I'm going to say today about water quality probably will go out the window, and I probably will be leaving Nevada for someplace where it rains. So this is probably the most important graph that is produced every month by the U.S. Bureau of Reclamation for the Colorado River Basin states. It's a prediction of how high the lake level will be over the next 24 months in Lake Mead, because this tells them when they might start taking shortages. To the left side is historical data where they actually have measured data. To the right side is predictions. And to be generous, they have used a very simplified model because it is understood well by all of the basin states, but is by far not the best model that could be produced. We could do a better job of modeling this, making this prediction, but it would take mathematical modelers, people truly schooled in modeling to understand it, not politicians, not water resource managers. So they stick with the simplified model, and it does tend to do what they need to do. So you can see that 2 years out from now, they're predicting that the surface of Lake Mead will be somewhere between 1,050 and 1,100 feet, with the most probable value being about 1,070 feet, 1,066 feet. This is important because this is where planning comes from. This is telling California that they need to store water for the next 2 years because they may not get all of their allocation. It's definitely telling Arizona that. Nevada, I'll show you in a minute, we're such a small player that we can take that kind of shortage without even noticing. So Nevada's almost, or not Nevada, Southern Nevada, Las Vegas, and the surrounding communities are almost completely dependent upon the Colorado River for our drinking water. The pie graph on the top shows the Colorado River as a resource and the 5 to 10% that we get from groundwater. Las Vegas only exists because of groundwater, but that was when it was a community of hundreds, not thousands or millions. If you've been here, you've seen the mountains to the west of Las Vegas. There's a beautiful mountain range right to the west. We don't have snow yet, but we do have snow in those mountains every year. They feed an aquifer system that does provide a lot of groundwater. But again, it's a lot of groundwater if your population is in the hundreds. The lower pie chart is how Colorado River water is allocated between the states. On the right side is the 3 upper basin states. Colorado gets the most, Utah gets the second most, then Wyoming and New Mexico both get a little bit. On the left is the lower basin states, California getting the lion's share at about 4.5 million acre feet. If some of you probably know this, an acre foot is the amount of water it takes to fill 1 acre, 1 foot deep. It's an old hydrologist, water resource manager term. Arizona gets 2.85 million acre feet, and Nevada's that tiny little yellow slice of 300,000 acre feet. So in the big picture of drought in the Colorado River, it would be devastating for the Nevada economy for us to go away, but shutting Nevada off doesn't really do anything to solve water resource problems for the West. So next I'm going to show a sort of series of slides of some water quality issues, things we face, and try to put them in context of how much Las Vegas and the surrounding communities affect the Colorado River. You guys are used to storms. As I say on the bottom of here, we have had 193 days since there was last measurable rainfall in Las Vegas. A rainy year in Las Vegas is a rainy day in Alfred. It's the talk of urban legend, well, rural legend, I guess, that I swear my freshman year at Alfred, it rained for 20 days straight. Not all day long, but some part of 20 days it rained. We don't see that here. We have 300 cloudless days a year. This summer, we also had 158 days of temperatures over 90 degrees. That only stopped last week. It was last Friday that we finally had a day where it did not go over 90 degrees. So storms are not a common event, but that should or could mean that they're significant events in terms of water quality. And in the end, they are locally, but not overall. So I pulled data from a 2013 storm, 2,000 cubic feet per second draining out of the Las Vegas Valley. As you see, our normal fluctuations are in the 200 to 300 cubic feet per second range. So about 10 times the average flow. The bottom graph is the turbidity in the lake. Once that water reached there, the two sets of data, the blue and the red, unfortunately the colors don't differentiate well. The blue and the red that show a pattern shows that storm water entered the lake at about 15 meters depth at about at locations about 2 and 4 miles from where the Las Vegas wash enters Lake Mead. So we could detect an impact between 2 and 4 miles, but by 6 miles, it was only a very small impact. And then at our drinking water intake, which is just beyond that, maybe at 6.5 miles, there was no detectable impact of it at all. So it dissipates quickly. And the infrequency of these storm events tends to minimize their impact. The one thing that I sort of continue to be shocked that Las Vegans don't understand is that on those 3 to 5 days a year where we do get a little bit of rain, every time it happens, we get asked how much the lake went up. The lake does not even budge, does not even think about moving for rainfall that is local. It is only rain that and snow that occurs in the Rockies that really comes to affect us, and that's 6 months later. So this is a complicated picture of basically the wastewater stream in Las Vegas. We get return flow credits, which means we get credit for wastewater that is treated and then returned to the Colorado River, and then we can use that as part of our drinking water allocation to take it back out of the lake a second time, a third time, a fourth time. This is a pretty critical part of our portfolio. It's also why there's almost no water reuse in Las Vegas. It's been decided, and this is before I got here, presumably been determined, actually evaluated in meaningful ways, that it is more valuable for wastewater to go back to the wastewater treatment plants and back to Lake Mead and increase our allocation than it is to try to use that water for other purposes in the valley. So the picture on the bottom left shows basically how water is used. We pull it out of Lake Mead, we treat it here at the water treatment plant. Unfortunately, about 60% of it still is used for outside consumptive use. Again, if you fly into Las Vegas, there's a shocking number of pools, backyard pools. There's a shocking amount of green grass. I like a grassy park as much as the next guy, but I really question whether we should be using the amount of water that we do maintaining some of these green spaces. Public green spaces where everybody can use it works great, but as I'll talk in a little bit, we've worked hard as a water authority to try to reduce outdoor use in residential uses. Then the indoor use between the image shows the casinos, but most of this indoor use is actually homes. That indoor use is taken back to the wastewater treatment plants. I pulled from their website a description of their treatment pattern or treatment processes. Most of the treatment process, so their tertiary treatment, they truly have taken advantage of the money. Wastewater is a money maker for the municipalities. They've taken advantage of that money-making characteristic of it and done a great job of increasing every chance they get their wastewater treatment. So most of the treatment that matters to us takes place in this activated sludge, aerated activated sludge. They get their nutrient removal there. They get their organic matter removal there. The second part of it that really matters to us as a water agency is this ozone treatment, the ultraviolet disinfection. And lately they've added membrane filtration so that the water leaving the wastewater treatment plants bacteriologically is cleaner than the water in the Las Vegas wash that it enters. There's effectively no viruses and no living viruses, no living bacteria in the wastewater as it's released. So after the wastewater treatment, a large portion of that, about 99% of that wastewater makes its way back to Lake Mead. About 1% is sent off for reuse. We have there's a few gas-powered power plants in the Las Vegas Valley that use the reuse water for cooling. We had a few golf courses that attempted to use it. They decided the salinity of the water was too high and it caused problems for them. So they now use potable water for their golf courses. So one thing I mentioned is they get their nutrient removal through that activated sludge process. We care a lot that they remove as much phosphorus as they can. The picture on the right is an algal bloom. Before I got here in 2001, that is not a photoshopped image. That is really what the lake looked like. And it was an interesting circumstance of timing and conditions and of climate conditions for that year, that it happened early in the spring. The wastewater treatment plants, as I'll talk in a minute, we're not removing high levels of phosphorus yet. And there was a warm storm event, which carried that wastewater out across the surface of the lake, fed this algal bloom, and we could trace this algae as far down as Los Angeles, not at these concentrations, but we could find traces of this down there. The graph on the left shows why we care so much about phosphorus. If you look at the red dots, generally our phosphorus concentrations are between 4 and 10 micrograms per liter. This is pretty low. Out in the main body of the lake, we're generally below 2 micrograms per liter. The nitrogen concentrations in blue, somewhere between 800 and 1,000 micrograms per liter. So we have over 100 times natural nitrogen. This is Colorado River nitrogen concentrations. The background concentrations of nitrogen are about 100 times what they are of phosphorus. So phosphorus makes sense as the nutrient to try to control for Lake Mead. And the wastewater guys have taken that on, and since 2001 have managed, despite occasional failures, to keep phosphorus concentrations low enough that we've not seen a repeat of this algal bloom. So there's a graph of phosphorus being loaded to the Las Vegas wash. The red line is the population increase over time. They take great pride in this graph because they can show decreases in phosphorus loading with increasing population. So we start with this early period in the early 90s the very early 90s, where they really were not working to control phosphorus at all. They were loading over 700 pounds total phosphorus per day to Lake Mead. Then we moved to the period from 92 to about 2001, 2002, where seasonally they would remove phosphorus down to levels of about 200 to 300 pounds per day. But then during the winter months, thinking that they would not have algal blooms because it was cold and windy. Cold is a very relative term. We generally have about 1 week of consistently freezing temperatures. 40-degree lows, 60-degree highs are probably more in line with what we see most of the time. So during the winter months, they did not remove phosphorus. During the summer months, they did. Then they had the 2001 algal bloom. They managed to get some of excess phosphorus removal in 2002. But since 2002, with the exception of a couple of treatment plant failures, they've managed to maintain phosphorus concentrations in the 200 to 300 pound range. They shoot for 230 pounds per day. That's what the state mandates. And with that level of loading, they've managed to keep phosphorus concentrations and thereby algal concentrations under control. I took out a couple of graphs. I talk about this. I'll talk about the ones I took out. So this is chlorophyll concentrations at our drinking water intake. So this is a measure of how much algae there is in the water. 2001 algal bloom, it did not end at 14 micrograms per liter. We actually had measurements over 1,000 micrograms per liter, but that just swamps this graph entirely if you leave them in. 2002 through 5, they were optimizing their treatment removal. By 5, they had really gotten it down. So we started seeing our algal concentrations or chlorophyll concentrations at about 2 micrograms per liter. And that's where they remain today. I add to this that we did pick up the quagga mussels in about 2007. The quagga mussels now, the description I give of them is that they remain in the lake, but they are so food limited because there's so little algae that we will never get rid of them, but they will never be the problem that they are in some other lakes that have higher productivity. The graphs I took out, we've done some modeling, extensive modeling, showing how much phosphorus enters the lake in terms of bioavailable phosphorus, the phosphorus that algae can use effectively immediately or nearly immediately without transformation. Most of that comes from the Las Vegas wash and is wastewater derived, even with that relatively low loading of 230 pounds. Most of the phosphorus overall, about 1,000 pounds per day, enters through the Colorado River, but that's all attached to sediment and mostly settles to the bottom and then is not bioavailable. Long term, that's a problem or could become a problem, but in the short term, it's not. But that they've gotten to the point that the Colorado River is now the larger source. So when I move over to the research and development group, one thing they've spent a lot of time looking at in the water reuse context is pharmaceuticals, personal care products, flame retardants, steroids, and other unique organic compounds, mostly organic compounds, some metals, that let's say are of interest. Some of them are of interest because we can use them as tracers. Caffeine, we basically measure because it's a good tracer. It's not easily biodegradable. And we can trace how much wastewater we are taking into our drinking water intakes. In the past, we used caffeine. The highest that number ever got was 1%. So in the pharmaceuticals, you know some of these names: the ibuprofen, naproxen, painkillers, some antibiotics, some other general use drugs. For the personal care products, the DEET, it's a insect repellent. Sucralose, which I'll talk about in a second. Triclosan, the antibacterial component of antibacterial soaps. Triclosan that doesn't work particularly well from everything I've ever seen. We can measure that in the wastewater and then in the lake. We're talking about nanogram per liter concentrations for most of these, so very low concentrations. TCEP is flame retardant that seems to wash out of clothes. That's about the only source we can come up with for that. And then, of course, the various hormones in birth control pills, other hormonal treatments that tend to make it through the wastewater treatment process. So I've got the Splenda picture. That's sucralose, or that is the sweetener in sucralose. And that the table on the right shows sucralose concentrations in nanograms per liter moving through the wastewater, drinking water, and then lake water processes. So if we start at the top, the water flowing into a wastewater treatment plant comes in at about 30 to 50,000 nanograms per liter. Leaving the wastewater treatment plant, we're at about 30,000 nanograms per liter. So not a lot of degradation of sucralose in the wastewater treatment process. Probably more, this was before they had ozone for their disinfection. The ozone probably does a good job of oxidizing some of this, but from what I've seen in other studies, it does not eliminate it. That 30,000 persists through the Las Vegas wash. So there's nothing in the Las Vegas wash, which is basically an urban stream, that breaks it down. It makes its way to Lake Mead. So Boulder Basin at the Narrows is unimpacted by the Las Vegas wash wastewater. So flowing out of Grand Canyon, there's about 500 nanograms of sucralose from upstream users and their wastewater discharges. Leaving Lake Mead at Hoover Dam, we add a little bit to that. Dilution continues to be part of the solution here. So leaving Hoover Dam, it's about 600 nanograms per liter. Our drinking water intakes, we only get part of the dilution effect. So we're at about 800. Our treatment process only takes that down to about 500. And then what's interesting to me, and this may be a Las Vegas specific thing, our urban runoff has between 70 and 400 nanograms per liter, probably because it's being irrigated with potable water, falling on the urban and then forming that urban runoff. So that's really coming from us. Sucralose, there's a reason that humans don't digest it. It seems to be that nothing digests it well. So this is now our new tracer of choice. And we continue looking at it. And this has been adopted in a lot of water reuse context. It's been used in groundwater. Any place that there's a chance interaction with wastewater, sucralose seems to be a good tracer. So we do also get impacted by what goes on at Lake Powell. So Lake Powell is about, well, from here, it's almost 500 miles. It's 300 miles, 250 miles, no, 300 miles from the intake, the inflow to Lake Mead, flowing through Grand Canyon. So this is not a urbanization. This is not a human impact in large part. This is a natural area. So in 2013, temperatures leaving Lake Powell reached about 10 degrees in May, 12 degrees in September, and really only got above that ever so briefly in late December. 2014, we were already at 10 degrees in April, 12 degrees by June, and exceeded about 15 degrees at the peak. So this is leaving Lake Powell. As this water comes down to Lake Mead, these small temperature differences make a huge difference in where that water winds up in the water column of Lake Mead. In 2014, so under normal conditions, the 10 to 12 degree water, that flows along the bottom of Lake Mead from the inflow all the way to the dam. It is cold enough, dense enough that the density gradient maintains an underflow through all of Lake Mead almost year round. Our surface water temperatures approach 25 to 30 degrees C every summer. So there's quite the density difference there. Well, because by June, we had this 12-degree water coming in already. It was already starting to separate from the bottom, and we started to see oxygen be consumed by the bacteria primarily in the sediments and associated with the sediments where the Colorado River enters Lake Mead. And then what we saw was that a combination of continued consumption of that oxygen in the inflow with just hydrologic movement of that water swept that low oxygen region in the end almost 20 miles into Lake Mead. This is not something we typically see at the Colorado River influence. We see it at the Las Vegas Wash where we have that wastewater influence, but not so often under the more natural conditions, as much as a reservoir can be natural, but the conditions that we see other times. And the reason we start to care about this is become critical habitat for 1 or 2 endangered fish. And if those endangered fish were to become entrapped in these anoxic regions of the lake, we could have fish kills, which would then bring Fish and Wildlife Service down on, I'm not quite sure who, because ultimately this is 2 national recreation areas and a national park that are quote unquote causing this problem. It's the dam that causes the problem, but it's managed as national recreation areas. So this is one of the things we keep looking at. We've seen this before, we'll see this again. It totally is driven by the temperature being released through Lake Powell, which is why we worry about a combination of climate change and just lower lake levels in Lake Powell. Lake Powell releases cold water because it's another very deep storage reservoir. It has 10-degree water to release year round. Well, if that water by climate change warms 2 to 4 degrees, if that lake level drops so that their intake is now releasing surface water, we'll see a whole different picture. Probably seen in the paper Grand Canyon high flow experiments to try to build beaches. These are really interesting experiments trying to lift sediment from the bottom of the river to build beaches. Partly the lower right picture shows it so that rafting trips have a place to camp. The biological justification for this is to build these backwaters that should be warmer water for native fish to breed and inhabit. Again, back at the Colorado confluence, specific conductance, basically the salinity of this water is a great tracer for us. The water leaving Lake Powell is less saline, lower conductivity than the water in Lake Mead. Evaporation drives our conductivity up. So again, we see that water coming in, plunging, and then traveling across the middle of the water column in this year. This is 2012 data. They do these about every other year. They do it every time they have enough water and enough sediment to do it. 2012 just happens to be a year that we were able to get really good data for Lake Mead. We see with that it carries turbidity, again, 15 to 20 miles into the lake. We care about this as a water agency a lot because Lake Mead is a wonderful settling basin. It removes so much of this turbidity naturally that our treatment processes aren't designed to treat turbid water. As I said at the beginning, I came from Mississippi. The drinking water in Mississippi is more turbid than the water leaving Lake Mead to come into our treatment process. Fortunately, we have another about 70 miles before we'd have to worry about this. But it is another thing that we model and we're looking at to figure out when we will need to start adding treatment processes. When I first put this talk or parts of this talk together, one of my sort of themes was why water quality in Lake Mead remains so high, given that in the lower part of the lake, urban influences have increased. The water level has dropped over 150 feet at its peak. And you know, overall, things should not be trending in a good direction. And the place I wind up is that it's water turnover time in the reservoir, that the period of time any given drop of water spends in the lake is between about 1 and 3 years. And it hasn't varied that much over the history of the lake. It's varied between 1 and 3, but it's never gotten longer than 3. And for a lake this size, that's a very, very short amount of time for water to remain in the lake. It's calculated just by calculating the volume of water contained by the releases. This has to be a big part of why our water quality has remained high. The efforts of Las Vegas to maintain this have helped, but it's that water's moving through the dam quickly down to Arizona, down to California, that really has helped us a lot. Starting to run out of time. Let's skip that. So I last time I gave part of this talk, I showed a clip from Chinatown. If you haven't seen Chinatown, I encourage you to. It's classic film noir. But to me, it's actually much more interesting and much more descriptive in describing the water fights, the battle, the importance of water for California, for Las Vegas, for Arizona. This is a series of dialogue from it, talking about how one of the main protagonists is fighting against this water baron, clearly based on some of the real life water barons of Los Angeles. And the last line to me says it all: either you bring the water to LA or you bring LA to the water. And at this point, they've done both. They've built a pipeline that crosses the desert to bring water to California, and California has spread out to where there is water. It's amazing to me how well in this classic film noir, they really caught the water battles as a secondary story to the crime drama, as it were. So Las Vegas is part of this problem. On the bar graph on the top is population growth in Las Vegas since 1950. Las Vegas has gone from about 35,000 people to 2.69 million people over that 70-year period. You see that most of that growth has happened since about 1970, 1980. Pulled two figures from the NASA Earth Observatory: Las Vegas urban area in 1984 versus the urban area in 2009. They used to have on the Earth Observatory website a slider that you could look and move it back and forth and look at specific areas, and it highlighted a little bit better. But we've done the same sprawl that Los Angeles has, just on a much smaller scale. We are approaching the limits of what we can do. One thing that I find really interesting in Las Vegas and parts of California is the abruptness with which cities end. When you reach the end of a water line, a power line, a sewer line, that stops development. There is no real development out in just these slightly more rural areas, because there are no services, and that will stop it. And there's no opportunity for groundwater. So if you aren't connected to us, the drinking water provider, you're pretty much out of luck. So what are we doing to ensure the future of water? The most important part of this is the Colorado River is grossly over appropriated. They determined how much water could be pulled out of the Colorado during a period of high flow, and now we're in a 20-year period of low flow. So Lake Mead is only going to continue going down. We have water rights that are secondary to California but superior to Arizona, so we worry, but we don't worry as much as Arizona does. But we've spent a lot of money and a lot of time working on different things. In terms of managing demand, new houses, new construction in Las Vegas cannot have lawns in front of their houses or in front of their properties. They still can have lawns in the backyard, but the front yard has to be xeriscaped, has to be landscaped as a desert. Encourage or require water conserving fixtures in new construction. This has really gotten to the point that it's required. For a while, they required that hot water heaters have circulating pumps, because they wanted to eliminate that lag from the time you turned on the hot water to the time you got hot water at the tap, and that water loss. We pay customers to remove their grass. We pay for pool covers. Again, I'm shocked at the number of people who want to have pools here. It's almost unusable during the summer. They get so hot, but people want them. So we pay them to cover them and reduce that evaporation that way. We've lately been moving to smart irrigation controllers. These are internet-based irrigation system controllers that automatically adjust watering cycles based on the weather, based on the time of year. So it eliminates some of the human need to control those things. I said before, we do very limited reuse. And to date, there are no limits on growth, no formal limits on growth based on water availability. For the first time ever this past year, our general manager announced that he was telling the municipalities that he foresaw a time when we could no longer provide water to new development. They've backed off on that a little bit, but the water authority's position has been, it's not our place to limit growth. That's for the municipalities to do. This is a fairly dangerous precedent, but I politically understand why they take it. Public education is a big part of this. One thing that I learned when I got here is that casinos really do only use about 3% of the water. That despite having 40 million visitors pre-COVID, that their indoor water use isn't that high. And if you just think about the time you spend in hotels, you take a shower, you use the faucet, the toilet, things like that, but you don't, run the tap all day long. So that water use is relatively low. And it's true that most of the outdoor water features, if you've seen the Bellagio fountains or other things like that, most of those are using salty groundwater that really cannot be easily made potable anyway. And then that water is also reused. They're switching to high efficiency cooling systems. So rather than the traditional cooling tower that just evaporate water away, they're recirculating more of that water. We do have 2 new water parks in Las Vegas that use half of the water they used in the past, but I'm still shocked to say the words, we have 2 new water parks in Las Vegas. They're a lot of fun. It's a great place to go and cool off, but it's also just a place where evaporation just sucks the water away. And all of the growth that went on during the 2000s, this is the graph on the right, basically used no more Colorado River water than we'd been using in the past, because we increased or decreased per capita use from about 350 gallons a day to about 200 gallons a day through these conservation measures. But we are approaching the point where conservation is only going to take us a fraction further. We will not get this down to 100 gallons today. We might get it down to 180, 175, but we're not going to get another 100 gallons per person per day out of conservation. We do a lot of public education. They run print ads, the get your head out of your grass to encourage people to remove their lawns. The there's nothing sexier than saving water campaign to get people to adjust their water clocks. We tend to employ advertising agencies that are rather snarky. We do this done other print ads where we remind people that they can only work here because there's water here, because we have this limited supply. Lately, we've actually, it's been outlawed to water your lawn on Sundays. That's an automatic 1/7 reduction. And then most recently, we've teamed with, now that Las Vegas has 2 professional teams, we've teamed with the professional teams, or players at least. If you want to go online and Google around, you can find Ryan Reaves. He's one of the Las Vegas Golden Knights. He is their enforcer. We have a couple of really snarky ads where he slides in, checks people, and tells them to reset their water clocks. And then now that the Raiders are in Las Vegas, there's a proposed $30 million marketing deal that will have us as one of the premier sponsors of the stadium and the Raiders, with advertising in the stadium. The Raider Stadium has the world's largest digital billboard. We will have ads on that. We will do a lot of advertising in the restrooms because they found that that's a really effective place to do it. And to me, one of the best parts of this is that the Raiders will convert 2 high schools from grass to synthetic turf, reducing that water load every year. Expanding the supply is easier than it seems, but not as effective as would hope. I already talked about return flow credits. We're making the most we can out of this. We will squeeze whatever we can, but there's not much more to be gotten out of return flow credits. In the past, these recent surpluses, notice this is late 90s, early 2000s, that's the last time there were surpluses. When the Colorado River has excess water in it, water in excess of what's been allocated, that water is available to be taken. California in the past has taken a lot of that excess water. This is not a route to water use in the future. We've done other intentionally created surpluses. In and around Las Vegas, we've bought water rights from farmers. They fallow their land. We take their water rights, transport it to that water to Lake Mead. The Drop 2 storage reservoir, this is a reservoir built along the Mexican border. The picture shows the border where somebody would like to build a fence. What this is the All-American Canal is one of the major irrigation canals for Southern California farming. When those farmers request water, they request it from Lake Mead. It takes about 3 days for the water to make it to the All-American Canal, where they will then remove it from the river. If in the meantime it rains, they no longer want that water. They let it go. In the past, that water was released to Mexico and no one got charged for that water being used. So being good water resource accountants that U.S. Bureau of Reclamation is, they figured out that they could build a reservoir right along the border, this large reservoir, and capture that water in that reservoir when it was asked for but not needed, and shortchange Mexico that way. It's a creative strategy, but it's not one that's good for the overall health of the Colorado River. In water accounting, it works great. In biology, in environmental conservation, it's not a good plan.
Todd, I'm going to break in here a minute. I've got to leave to go to another class, but finish up. People ask questions at the end, and yeah, sorry, I have to.
Thanks. I'm just about done.
Okay.
We do a lot of water banking. We pump groundwater or pump surface water into groundwater in Arizona, California, and in Southern Nevada. This costs money. It requires there be excess water. The biggest limitation on this is you can't pump that water out as fast as you can pump it in. Desalinization always comes up. Desalinization is mostly a failure. The picture on the left is a desalinization plant in Carlsbad, California, about halfway between Los Angeles and San Diego. The only reason this plant works is it's co-located with a gas-fired electric plant. So during the night when electricity is in lower demand, they turn on the desalinization, take the electricity. During the day, they shut it off. This is a totally private enterprise supported by the state, but it's supposed to make money. It has not yet. It's been online for 2 or 3 years now. On the right is the Yuma desalting plant. This is a desalinization plant built in Yuma, New Mexico by Ronald Reagan. It's only been run twice, and those were for tests. The plan here was to take salty irrigation runoff, remove as much of the salt as possible, and then pass it along to Mexico to meet that demand for water that Mexico has. Mexico also has a water right. We have also bought groundwater or bought ranches and the associated groundwater in northern Nevada. This plan has been killed since this slide was made. The farmers, despite us using the very same Nevada water rights that the farmers rely on, they fought this and did not want to let it happen because it meant a transfer of water from the upper counties down to Las Vegas. This was also a multi-billion-dollar project to build a pipe. Would have been a multi-billion-dollar project to build a pipeline and other things. And aside from buying the land, it never left the drawing board. But the Southern Nevada Water Authority is now the second largest rancher in the state of Nevada. The largest rancher are the gold mines. So what's the future hold? 20 years of drought has not been good, but mostly it's been a water resources issue, not a water quality issue. This continues to be over appropriated, so this is not going away. I tell people that I expect to see Lake Mead full before I retire, but that's not optimism, it's just variability. With 3 to 5 years of good snowfall in the Rockies, I pray every year for Colorado to have an amazing ski season. With 3 to 5 consistent years of that, we would see Lake Mead full again. Water utilities are doing what they can, but as long as people want to come here, we are going to work to provide them with water. And I'm not quite sure how that's going to get resolved. The last point, the conflicts between population centers and farming are going to increase. This is a really big problem in California. San Diego desperately wants to buy water from the farmers in the Imperial Valley. There's a faction of farmers that want to use that water that way because they can basically sell out their farm, sell out their water, and retire someplace. There's other farmers that just see that as a pathway to losing too much. So, sorry for going long, but I'm happy to try to answer any questions.
Okay, I'm just gonna jump in real quick. Michelle had to leave, but if you guys have any questions, feel free to write them in the chat or unmute yourself and ask. Thank you so much, Todd. This was really excellent. A lot of good information, and I suspect there are going to be some questions. Do you have time to hang out?
Yeah. Oh, yeah.
Okay.
So we've got a couple of comments already. Somebody commented abolish lawns. I tend to agree with that. And Las Vegas, I mean, I'm not a vocal supporter of the general approach in Las Vegas. We do some really good things. California came to Las Vegas for conservation strategies because we were that far ahead of them. But we do still basically allow and not charge enough for water that front lawns are still a thing. When I moved into my house, we had one. I took it out. They paid me to remove the lawn, and was happy to do that. If you go to Phoenix, Phoenix is so much worse than California or Southern California. You go to business parks where you know the only person who ever walks on that lawn is the guy who mows it, that there's no reason for those grassy spaces to exist. And, you know, when done right, the xeriscaping, the desert landscaping really can look pretty good. To what extent do Las Vegans pay the full cost of their water and water treatment? That's difficult to answer. The cost of water treatment, they do pay the full cost. The Water Authority is actually a nonprofit utility. So they do have to cover the full cost of treatment. However, we get the water for free. So we don't pay Bureau of Reclamation for the water that comes out of the Colorado River. And we get a large portion of our electricity, which is our second largest cost, not for free, but at greatly reduced rates, because we get most of Nevada's allocation of Hoover Dam electricity. So they are not paying anything close to the real cost. So yeah, I again, this is why I do water quality, not water quantity. And I'm even further from an accountant than a water resource manager. I don't know what the real cost would be. It has been there. There are a few groups really pushing hard for conservation that have made some calculations, but they mostly focus on California than not Nevada, because we are such a small player.
Okay.
I have a quick question if you're able to hear me.
Sure, I can hear you.
So earlier you had mentioned how companies will choose not to go through lawyers and the whole legal process and instead deal with it in-house in a way. Do you find that that's useful?
Yeah, it's not companies that are doing that. It's the states that are doing that.
Oh, okay.
Yeah.
Do you find that that's useful for environmental purposes or just for speed purposes? Do you think it just makes the process quicker, or do you think it's actually still helping the environment to the extent that we would like it to?
So for the first, 70, maybe 80 years of the process, there was no there was interest, but there was no vocal environmental interest. It's really, I may be exaggerating saying 70 years, but for the longest start of the Colorado River Compact, there really was no interest. The interest in environmental issues really came up because environmental groups pushed it when they went to refurbish the turbines at Glen Canyon Dam. And they pushed and got required an environmental impact statement for the replacement of those turbines. And that's what's driven so much of the environmental interest. Having said that, so there are the Grand Canyon Mining Research Center, there's a adaptive management work group, there's the multi-species conservation recovery plan. There are a lot of plans that have come out of that that are working to resolve some of these environmental issues. And every last one of those will be dropped the second that serious cutbacks in water deliveries come into effect. That most of those projects are paid for with power revenues from the dams. So the money will dry up, and the political will to worry about the humpback chub or the razorback sucker or the southwestern willow flycatcher or environmental flows in the river to Mexico and maybe occasionally reaching, the Gulf of California, those will be dropped the second that water supply issues for populations in agriculture really get threatened. I am unfortunately just completely confident of that. So it's working now that things aren't terrible. As they get terrible, I suspect they may stop.
Okay, is there anyone else who feel free to unmute yourself?
I'll just want to put a plug in too, that if you've not been to the Desert Southwest, I really strongly encourage you to come. Las Vegas actually is a great base from which to explore Grand Canyon, Zion National Park, Bryce Canyon, another national park, Death Valley. So we've got a range of state parks also that are nearby. And the landscape, I know they call Letchworth the Grand Canyon of the East. It ain't. It's a beautiful place. I love going there, but it's a totally different world out here. So if you ever have the chance, I'd strongly encourage you to come out and take a look. And if you happen to want to gamble, it keeps my taxes low.
Awesome. Thank you so much, Todd.
Glad to do it.
Really appreciate it. And then I guess I'm going to stop the recording now. If anyone has anything, feel free to chime in.
All right. Thank you.
Thanks.